Hi, this video is about terminal velocity. Is it true that a cat can survive a fall from any height? I've heard that before, and I've seen some videos of cats jumping out of burning buildings from really high up and they land on the ground and just spring right up on their feet. How is that possible that cats can survive such a big fall when it would be deadly to humans? Well, the answer lies in forces. So let's review what we know about air resistance. As something falls down, it starts to speed up. So I've got an example here of a skydiver. That's what we're going to use as our example. And as the skydiver gets faster, or as any object gets faster, it runs into more and more air molecules each second, and air resistance increases. So you go from a little bit of air resistance, and as you get faster, the air resistance goes up. The faster you go, the stronger the air resistance. So let's apply this to a skydiver. As a skydiver jumps out of a plane and drops out, initially they're moving very slow. And so initially that means that the air resistance is negligible. You're not going fast enough for the air resistance to really matter at the beginning. So the only force that's acting is the force of gravity, your weight pulling you to the earth. So if we analyze the situation by talking about the velocity, net force, and a description of what's happening, the velocity is down because you're moving down. The net force is also down because there's nothing else pulling on you except gravity. And so you are speeding up because your velocity and net force are in the same direction. You're being pulled further down. But as you start speeding up, you start to develop a little bit of air resistance. So here, this little tiny bit of air resistance is now starting to cancel some of the effects of that gravity, not fully though. So the net force is still down and you're still speeding up. As time goes on, you gather more and more air resistance as you gather more and more speed. And so this speeding up effect starts to get lessened over time. Still though, you're moving down and your net force is down, so you're still speeding up, just maybe not as quickly. Well, eventually, what's going to happen when you go so fast that the air resistance equals the gravitational force? Well, when that happens, something different happens. Eventually, you fall fast enough so that air resistance and gravity are equal. Your velocity is still down, but now the net force acting on you is zero. There is no net force. The forces are balanced. And when the forces are balanced, objects naturally continue moving at a constant velocity. So you're going to move at a constant speed falling to the earth now, not getting any faster. So getting fast enough results in the air resistance becoming so strong that it neutralizes the effects of the gravitational force and the object no longer speeds up. So the velocity that a falling object ends up going, or in other words, the velocity that it terminates at, is known as the terminal velocity for that object. So for human beings, typically a human being's terminal velocity would be about 120 miles per hour. And that, of course, can be lessened if you spread out more. If you were to just dive feet first and you have a very small surface area penetrating through all the air molecules, you could actually get up to speeds over 200 miles per hour. But spreading out, kind of like this, 120 miles per hour is a human being's terminal velocity. For a cat, however, cats' terminal velocities are lower than humans. And that's because they're able to maybe spread out a little bit more, gather more air resistance. Also, they're not as heavy, so they don't need as much air resistance to counteract that force of gravity. So a cat's terminal velocity is 60 miles per hour, and this allows them to theoretically survive a drop from any height. So lucky them. Now, let's talk about one last thing that happens when you're skydiving, because it's a good example for us to think about in physics. When you open up your parachute after falling at terminal velocity, opening up your parachute suddenly collects a lot more air. And so your air resistance suddenly explodes. You have a lot of air resistance compared to your weight. And so when this happens, if you look at the net force now, the net force is up. Now, this doesn't mean that you start moving up. You're still falling. you were falling really fast, like 120 miles per hour down, you're not suddenly going to be moving upwards. No, what this means is when the net force is up and the velocity is down, now you're slowing down. So no longer are you going 120, now you start to go 110, 100, 90, you start slowing down, and eventually your slowing down causes the air resistance to get weaker as well. Remember, air resistance and your speed kind of go hand in hand. So if you start slowing down now, your air resistance gets lower and lower until eventually it actually matches the gravity again. And when this happens, you're falling at terminal velocity again, only that terminal velocity is slower than it was before. So this allows a skydiver to be safe when they land because they're falling at a new terminal velocity that's slow enough that it doesn't hurt them when they hit the ground. So that's all I've got for you in this video. Remember, happiness is not having what you want, it's wanting what you have.